All right, so I think I'm recording. We have been looking at skill packet 3, which is relations and functions, and more specifically, we were looking at the operations on functions. By operations, we don't mean operations like in a health class. Operations are addition, subtraction, multiplication, division, and when it comes to functions, there's a new operation called function composition. And whenever we're building new functions, we're almost always interested in the domain of these new functions. So that's what we're doing here in this homework. We are finding the domain of the function composition f composed with g. Now, it's a little bit surprising, or at least I always thought it was surprising, that I don't have to find the actual function itself, the equation for f composed with g, that I can use the idea of how it was built to find the domain of the composition. And how these compositions are built can kind of be described as a assembly line that we start with some number that's in the domain and we plug it into the second function g, and g does its rule and produces an output, and the output of g then becomes the input of f, and the output then is our final answer. So we have an x that we plug in, and we have an f composed with g of x that comes out. A number that goes in has to have a number that comes out, and to be a function. Every element in the domain corresponds to a unique element in the range. So let's see if we can't find the domain for this f composed with g. Two things always have to be true to be in the domain of a function composition. First, right off the bat, the numbers that you're plugging in have to be in the domain of g, or otherwise the output of g will be undefined and you won't get all the way to the end. Next, the output of g that now goes into f has to be in the domain of f, because if it's some value that causes that f can't calculate, f can't work with it because it produces something that's undefined, and we can't have that. So both of these things have to be true. And normally it's easiest to see the first one right here, the domain of g. When we look at this function g, we don't have any square roots, so we don't have to worry about taking the square root of a negative number. We do have a variable in the denominator, x minus 3. Well, 3 minus 3 is going to give us 0. So if we inputted a 3, what comes out is undefined, and f doesn't have any number to do its arithmetic on, so it stops right there. So we need to throw 3 out of the domain because it never gets it to the end for a value in the range. All right. Well, the next thing that we're interested in is the output of g has to be able to pass through f. Well, we could look at f and see what's in its domain. We look at the denominator here because there are no radicals. We see x plus 1. F hates the number negative 1 because negative 1 plus 1 gives us a 0 in the denominator. If we input a negative 1 into f, then what comes out is negative 6 divided by 0, which is not a number. So we can't allow that to happen. But we first have to figure out what value of x did you plug into g to get that output of negative 1 so you can avoid this ever happening. G of x, the output, can't be a negative 1. So what was the input into g that caused this disaster that we want to prevent from happening? So g of x is this fraction x plus 2 over x minus 3. You plug in values of x and do that arithmetic, and it'll produce output. We want to see what input will cause an output of negative 1. So if we cross multiply, we've got x plus 2 is equal to negative 1 times x minus 3. So let's solve this equation. To solve linear equations, we just get the x on one side and the numbers on the other. But first, let's distribute that negative 1. So we have x plus 2 is equal to negative x plus 3. Let's add x to both sides. And doing that, we get a 2x. Let's subtract 2 from both sides, and 3 minus 2 is 1, and x is equal to 1/2. So what this is telling us is that if you plug in 1/2 into g, you're going to get an output of negative 1. If we plug in if we plug in 1/2 into G, what's going to happen? If we plug in 1/2 into G, the output is -1, and when we plug in -1 into F, F just goes crazy and says, I can't work with -1. It causes division by 0. G, what were you doing to me? You know better than to give me a -1. So G has to remember, boy, I can't use 1/2 because if I accept the number 1/2, then I produce the number -1, and F just can't handle it. So these are the two values that we exclude from the domain. The domain of fog. We threw out the number 3 because it was G that refused to work with the number 3. It would not give F any input. Then we have to throw out the number 1/2, not because of G. G doesn't have a problem with 1/2 at all. G will produce an output of -1, and F has a problem with -1. So that's why we have to prevent the intermediate value from being -1. We have to go out to the front and say, don't plug in 1/2, because that produces an output of -1, and F can't handle that. So there's our domain for the function composition F composed with G, given these two functions. All right, let's do our last problem here. And it's the same idea. We've got these two functions, F and G. We're interested in finding the domain of their composition, F composed with G. And two things have to happen. First, the numbers that we plug into G have to be in the domain of G. Otherwise, there won't be an output to plug into F. The output of G has to be in the domain of F, or otherwise, if F refuses that number, then we don't have a final answer, a final output. So if we look at the domain of G, that's pretty easy to see what's going on here. We've got 2x minus 5 is in the denominator. We can't allow that denominator to equal 0, which means that we can't have x to be 5/2, because if we plug in 5/2 into G, then we get something that's undefined, an output that's undefined. So G refuses to work with 5/2. All right, now, what about F? Is F very picky? Maybe F takes all real numbers. Maybe F is just as happy as can be. But I don't think so, because when we look, we see a variable in the denominator, and the output of G, F will refuse to work with the number 2. So if we have a number 2 here, then F just goes, hey, I can't handle that. I get something that's undefined. I can't do my job and produce a number, so don't give me the number 2. Well, where did that number 2 came from? It came from G, so we have to figure out what input into G caused that output of 2, and then we have to prevent that from happening. So G was the function x plus 4 divided by 2x minus 5. We temporarily let it equal 2, solve this equation, and to know what x produces an output of 2, and then we need to keep that from happening. So if we cross multiply, we've got x plus 4 is equal to 2 times 2x minus 5. So let's see if we can solve this equation. Let's use the distributive property on the right-hand side. We've got x plus 4 is equal to 4x minus 10. All right, so if I subtract x from each side, I get 3x minus 10. If I add 10 to both sides, 14 is equal to 3x. Oh, I still need more room. And if I divide both sides by 3, I get 14 over 3. So what have we just found? Well, we just have found that if we input 14 over 3 into G, the output will be 2, and we want to prevent that from happening, so we have to throw out x is equal to 14 over 3. So let's see if that indeed is true. Check real quick on a calculator. If I have 14 over 3 in for x, 14 divided by 3 plus 4 is the numerator g, and then 2 times 14 divided by 3 minus 5 is the domain for g, and I claim that this should equal 2, and it does. And we want to prevent that from happening. So that f, never sees 2, g doesn't want to have 14 over 3 as its input because it can't help it. It'll have an output of 2, and then f goes crazy. So we need to avoid these numbers. Well, 5 divided by 2 is 2.5, and 14 divided by 3, well, 15 divided by 3 is 5, so this is a little less than 5, so the 5 halves is a smaller number. And we need to know which one is the smaller number when we write our interval notation. So the domain for this fog from negative infinity to the smaller number, which is 5 halves, 2.5, and from 5 halves to the bigger number, 14 over 3, which is just less than 5, like 4 2/3. All right, so there's the domain of that. That's our final answer. And so, hey, I hope that helps, and I will talk to you later.